Talking about the elimination method. It's a method of solving systems of equations by adding or subtracting so that you can eliminate one of the variables. Go ahead and stop the video and copy down these first two sections so that you have these notes to refer to while we're working examples. Okay. Now that you've gotten this copy down, we're going to talk about the steps to solve. And step one is probably one of the most important things you need to pay attention to. And I highlighted it because you need to make sure that when you're doing this, that the equations are lined up, meaning your x variables are on top of your x variables, your y variables are on top of your y variables, as well as the equal signs too. The equal signs should be on top of each other so that you have everything in the right place when you're working. The first thing we're going to do is we're going to decide whether we're going to add or subtract to eliminate the variable. And you need to look at common coefficients. Common means it's the same number that's before the same variable. So if you're looking at the x variables, you want to make sure that they both have, that they're lined up and that they both have the same number in front of them. If they don't, you can't use that variable to eliminate. So, and then you're going to look to see if the signs are the same or the difference. If they have the same number, then you look at their signs. If their sign is the same, you're going to wind up subtracting the two equations. If their signs are opposite, you're going to wind up adding the two equations. Let's go ahead and look at question number one. Question number one simply says, they're both in slope-intercept form, and you'll notice that the y's are on top of y's, the equal signs are on top of each other, the x's are on top of each other, and the constants are on top of each other. That's very important. So we're going to look here at the variables' coefficients. The y's have positive 1s. The x's, one has a 3, one has a 1. So we're going to see that the common ones, the common coefficients, are in front of the y's. And we're able to decide, since they're both positive, that we're going to subtract the two equations from each other. So we're going to subtract them. Let's go ahead and do that. You'll say subtract within the same variable. You're going to have y minus y, which is 0. You can have 3x minus x. That gives you 2x. And 4 minus a negative 2, well, that becomes 4 plus 2, which is 6. And that gives us an equation with one variable. When we have an equation with one variable, that's pretty easy to solve. You just want to get that variable alone. So we're going to start by subtracting 6 from both sides. That will cancel out that constant. And then we're going to see that we have 2x is equal to negative 6. Divide both sides by 2. We're going to have x is equal to negative 6 divided by 2 is negative 3. That finishes step 3, down to step 3. Step 4 says take the answer that you got and plug it back into one of the two equations, and you'll see that we have this situation here. We can plug that negative 3 in this case into any of those two equations, and I like to just do the top one. So we're going to have y is equal to 3 times x, which is negative 3. And then we're going to add 4 to that. And then we're going to simplify and see that 3 times negative 3 is negative 9. And then we're going to add 4 to that, and we're going to see that y is negative 5. If we did the same thing to the other equation, let's go ahead and just see that. When I plug the negative 3 into the other equation, I get negative 3 minus 2, and that's also negative 5. So you see we get the same answer for both, which is a good thing. So our answer is always expressed in a coordinate pair. The solution to the equation is always expressed in a coordinate pair in x comma y format. So you're going to get negative 3, negative 5 is negative 3, negative 5 is the solution to that equation. Let's look at another example. Here's two examples. Let's go ahead and skip down here at the bottom. Here's two examples. Let's do this one here. This one is in standard form. They're both in standard form. So we're looking again at their common coefficients. We see these are both 3's here. One is a negative 10, one is a negative 9. So we want to look at these two here. They're common, and they're both the same sign. So the same sign means we're going to subtract them. And so we have 3x minus 10y equals 14 and 3x minus 9y equals 15, we are going to subtract these two equations. So 3x minus 3x, well, that gives me 0x, and we can just see that those eliminate each other. And we get negative 10 minus a negative 9. Negative 10 minus a negative 9 gives me negative 1, because that's negative 10 plus 9, which is negative 1. Negative 1y. And then 14 minus 15, well, that as well as negative 1. And since we don't want a singular negative variable, we want a singular positive variable, we're going to divide everything by negative 1 by that coefficient. And we're going to have y equals positive 1. We can plug that into either equation. I'll just plug it into the top. 3x minus, well, 10 times y, which is 1, minus 10 times 1 is equal to 14. Finish this equation. We have 3x minus 10, and multiply those together, is equal to 14. I'm going to add 10 to both sides. When I add 10 to both sides, I get 3x, and those cancel, is equal to 24. Divide both sides by 3. We're going to see that x, since those 3's cancel each other out and gives me a singular positive variable, 3x equals 24, both sides divided by 3, we get x is equal to 8. The answer is 8, x comma y, 8 comma 1. And there's my coefficients. You go ahead and do these other two on your own. We'll check them in class. Let's go ahead and look at the next set of examples. We're going to do 5 and 7. 5 and 7 are going to be examples where we wind up adding, because we're looking at our common coefficients. Our common coefficients are both 4, but one is positive, one is negative. That gives me the ability to add my two equations. Remember, if my common coefficients are the opposite, I can add the two equations. So here I'm going to add these two equations. 4x plus a negative x gives me 0x. Those cancel each other out. And that leaves me to add 9 plus 7. We're adding these two. 9 plus 7 is a 16y. 5 plus 11 is 16 as well. When I divide both sides by 16 to continue solving, I've got y is equal to 1. Plug this into the equation, and you'll see that 4x plus 9 times 1 is equal to 5. And to solve this equation, we'll go ahead and multiply out and get 9. And then we'll subtract 9 from both sides. And that'll give me 4x equals negative 4. Divide both sides by 4. I get x is equal to negative 1. That gives me a coordinate pair of negative 1 comma positive 1. And there's my coefficient, not my coefficient, my coordinate pair that tells me where these two equations cross. That's the solution that makes both these equations the same on both sides. And it tells me that's the exact point where these two equations cross. Let's skip down here to number 7. Go ahead and notice that my common coefficients are 1 and 3. Those are not common, they're different. And then you got negative 1, positive 1. These are both 1s, but they're opposite signs. So when I add these two equations, these two variables cancel each other out, leaving me x and 3x, which is 4x. And 10 and 18 is 28. And when I solve for x, I divide both sides by 4. That gives me x is equal to 7. When I plug 7 back in, I get 7 minus y is equal to 10. And that way I can solve for y by subtracting 7 from both sides. And I get negative y is equal to 3. I don't want negative 1y, I want positive 1y, so I divide by that negative 1 coefficient on both sides of the equal sign, and I get y is equal to negative 3, and I have a coordinate pair of x is 7, y is negative 3. You'll see the rest of these are positions where we are not lined up. When 8 and 9, we're going to be lining them up. 10 and 11 are going to be lining them up, but 10 and 11 are going to be my examples where one I have a don't have a solution, the other one I have infinite solutions. So make sure you have all these examples down and you understand what we did for class next time. And if you copy these down, we'll make sure that you get those extra points that I promised.